Friends, I discussed the concepts of acids and bases and reactions of acids and bases with metals in the previous videos. In this video, I am going to discuss the reactions of acids with metal carbonates, metal hydrogen carbonates, and metal oxides with examples. Questions for self-assessment are also included. Let us do an experiment to understand the reaction of an acid with a metal carbonate such as sodium carbonate in the setup shown in figure 1. See here, take a test tube and place about 0.5 grams of sodium carbonate in the test tube. Then you add 2 ml of dilute hydrochloric acid to the test tube. Then you will observe the release of gas bubbles, which you call effervescence. And then you collect these gas bubbles through a delivery tube into another test tube which consists of lime water, that is calcium hydroxide solution. Then you will observe the formation of a white precipitate in this test tube. Let us see the inferences. Inferences from the observations in the experiment. Sodium carbonate reacts with dilute hydrochloric acid to form sodium chloride, water, and carbon dioxide gas. The chemical equation is given below. Na2CO3 solid plus 2HCl aqueous gives rise to 2NaCl aqueous plus H2O plus CO2 gas. Inference 2. On passing CO2 gas through lime water, that is calcium hydroxide solution, the following reaction takes place. CO2 gas plus CaOH twice aqueous gives rise to CaCO3 solid, that is calcium carbonate, solid, white precipitate, and water. The reaction 2 confirms that the gas released is CO2 gas. It is a test for the presence of CO2. On passing excess CO2 through calcium hydroxide solution, the following reaction occurs. CaCO3 plus H2O plus CO2. You are passing more and more CO2 gas. Then you will have formation of calcium bicarbonate, calcium hydrogen carbonate, CaHCO3 twice aqueous, which is soluble in water. There is another test also for carbon dioxide gas. If you keep a burning candle near CO2, the candle flame gets extinguished, puts off, as the CO2 replaces oxygen near the flame. Let us do another experiment in test tube B to understand the reaction of an acid with metal hydrogen carbonate, such as sodium hydrogen carbonate in the same setup as shown in the figure 1 earlier. Here also take about 0.5 grams of sodium hydrogen carbonate in the test tube B in place of sodium carbonate used in the previous experiment. Again here also add 2 ml of dilute hydrochloric acid solution into the test tube. Your observations and other experimental details are the same as shown in the figure 1. But in the experiment, the chemical reactions are as follows, because here we have taken sodium hydrogen carbonate. NaHCO3 solid plus HCl aqueous gives rise to NaCl aqueous plus H2O plus CO2 gas. See, and then CO2 gas plus CaOH twice aqueous gives rise to CaCO3 solid, that is white precipitate, calcium carbonate plus water. It may be noted that in both the experiments, the products are NaCl, H2O and CO2 gas. The products are same, only the balance equations are different. Therefore, in general, we can write the following word equation. Acid, any acid, plus metal carbonate or metal hydrogen carbonate gives rise to metal salt plus water plus carbon dioxide gas. See, limestone, chalk and marble are different forms of calcium carbonate which we use in our day-to-day life. These substances react with an acid to form calcium salt, aqueous, water and carbon dioxide. For example, with HCl aqueous, the chemical reaction is given below. CaCO3 solid plus 2HCl aqueous gives rise to CaCl2 aqueous plus H2O plus CO2 gas. Now, so far we have discussed the reactions of acids with metal carbonates and metal hydrogen carbonates. Now, let us discuss the reactions of acids with metallic oxides. Again, let us do another experiment. Take about 1 gram of copper to oxide in a beaker. So copper to oxide looks like this, as shown in figure 2a. Add dilute sulfuric acid slowly to copper to oxide while stirring simultaneously. What do you observe? This copper to oxide dissolves in dilute sulfuric acid and forms a blue colored solution as shown in this figure 2b, blue colored solution. This is our observation, but what is our inference? The blue color of the solution is due to the formation of copper sulfate aqueous. The chemical reaction is given in equation 8. CuO solid plus H2SO4 aqueous gives rise to CuSO4 aqueous plus H2O. This is the equation. Let us do another experiment. Again, take 1 gram of copper to oxide in a beaker. Now, instead of sulfuric acid, you add dilute hydrochloric acid to copper to oxide slowly. What do you observe? If the chloride concentration is higher, that means if the concentration of hydrochloric acid you have taken is more, then you will observe greenish solution. That is, copper to chloride is greenish in color when the concentration of chloride ion is higher. As the chloride ion concentration decreases, it becomes more and more blue. The chemical reaction is CuO plus 2HCl aqueous gives rise to CuCl2 aqueous plus H2O. Now consider another reaction between magnesium oxide and dilute hydrochloric acid. The equation is MgO solid plus 2HCl aqueous gives rise to MgCl2 aqueous plus H2O. Now, if you look at the equations 8, 9 and 10, what do you infer? In all the cases, there is reaction between metal oxide and acid. But what are the products? Metal salt and water are the products in all the cases. Therefore, the above reaction is similar to a neutralization reaction between a base and an acid. What does it mean? It means that the metal oxide is basic in nature. Metal oxides in general are basic oxides. Consider another chemical reaction between zinc oxide and dilute hydrochloric acid. The equation is ZnO plus 2HCl, ZnCl2 aqueous plus H2O. Interestingly, this zinc oxide also reacts with a base like sodium hydroxide to form sodium zincate and water. The chemical equation is ZnO solid plus 2NaOH aqueous gives rise to Na2ZnO2 aqueous, that is sodium zincate plus water. That means zinc oxide ZnO shows basic character in reactions with acids and shows acidic character in reaction with bases. Such type of oxides which exhibit both acidic and basic character are called amphoteric oxides. Other examples of amphoteric oxides are aluminum oxide and lead 2 oxide. Then you will have a question about the nature of carbon dioxide, which is the oxide of a non-metal, carbon. Its reaction with calcium hydroxide, which is a base. Calcium hydroxide is a base. Now let us see the reaction of carbon dioxide with calcium hydroxide, which is given in equation 14. CO2 gas plus CaOH twice aqueous gives rise to CaCO3 solid plus H2O. In the above equation, CO2 in aqueous solution reacts with a base CaOH twice to form a salt and water. This is also a neutralization reaction. Here, CO2 has acidic character when dissolved in aqueous solution and reacts with a base. In general, the oxides of non-metals are acidic oxides. Other examples of acidic oxides are sulfur dioxide, SO2, sulfur trioxide, SO3, and nitrogen dioxide, NO2. Nitric oxide and carbon monoxide, CO, are neutral oxides in the sense that they do not react with either acids or bases. Now, self-assessment quiz. Question 1. A compound A reacts with a dilute acid and produces a gas B. This gas is passed into a solution of calcium hydroxide and forms a white precipitate C. The substances A, B, and C respectively are option A, CaCO3, CO2, Na2CO3. Option B, Na2CO3, CO2, CaO. Option C, Na2CO3, CO2, CaCO3. Option D, NaHCO3, CO2, and CaO. Question 2. A metal oxide reacts with an acid to produce a metal salt and water. Then the metal oxide is dash. Option A, acidic oxide. Option B, neutral oxide. Option C, amphoteric oxide. And option D, basic oxide. Choose the right option. Question 3. Which of the following is the chemical substance present in marble? Option A, calcium carbonate. Option B, calcium hydroxide. Option C, calcium oxide. Option D, calcium hydrogen carbonate. Question 4. Metal compound A reacts with dilute hydrochloric acid to produce effervescence, that is gas bubbles. The gas evolved extinguishes, that is puts off, a burning candle. One of the products in the reaction is calcium chloride. Write the balanced chemical equation for the reaction. Question 5. Match the oxide given under A with the nature of oxide given under B. Choose the correct option among the options given below. Under oxide, I have given ZnO, CuO, CO, CO2. Under nature of oxide, it is given SD oxide, neutral oxide, amphoteric oxide, and basic oxide. Here, under options, against P, Q, or S, you have to choose right combination of acidic, neutral, amphoteric, and basic oxide. Option A, 4, 3, 2, 1. That is against P, Q, or S. Matching. Option B, 3, 1, 4, 2. Option C, 3, 4, 2, 1. Option D, 2, 1, 4, 3. So, among A, B, C, D, you have to choose the right option. Other questions. Write the balanced chemical reactions between potassium carbonate and also potassium hydrogen carbonate with dilute hydrochloric acid. Write a balanced chemical reaction between a basic metal oxide and an acid with a suitable example. Write an example of an amphoteric oxide. Write the balanced chemical equations between this oxide with a dilute acid and an alkali. Now conclusion. You may have watched my videos on concepts of acids and bases and acids and bases reactions with metals. Try to link the subject knowledge in this video to the knowledge you gained in my previous videos. Only then it leads to comprehensive knowledge, which is very important. You learn many concepts separately, but your mind should be able to see the interconnections between different concepts. That is important. Knowledge is unlimited. Enjoy learning new concepts and try to apply them to new contexts not taught in the class. I wish you the best in your efforts.